You might ask why even logic gates. The reason is in the CPU or in the computer, you're storing whether it's a 0 or a 1 bit um, with these little transistors. And with these transistors, you can make a circuit that will add up to a very big circuit. And that means you can add stuff, multiply stuff, and then eventually run all these programs. Yeah. Now, I will teach you the different types of logic gates, and then we will combine it to a logic circuit. The first type is the NOT gate. So it would just output the opposite value. For example, not 0 is 1 and not 1 is 0. So let's say this is called a truth table. Basically the values corresponding to each other. Our variable here is a, 0 and 1. The result of not a would be 1 and 0 because, yeah, they're the inverse. For the AND gate, it would output 1 if both are 1. For example, A and B are 1. 0 and 0, no, they're not. They're not both 1, so the result is 0, 0 again, and 1, 1, so then it will become a 1. Now, types of logic gates. We have the OR gate. So if either one is 1, either A or B is 1, then X will be 1. So you can see here 1, 1, 1, 1, 1, 1. The NOR gate, if neither A nor B is 1, then X will be 1. So this will only be true when they're both 0. The NAND gate, if both aren't 1, it will be 1, which is essentially just not of A and B, which basically means everything but when A and B are 1, it will be 0. XOR gate, exclusively OR, so A or B but not both, then it will be a 1. That's why it's called XOR, exclusively A or B, but not A and B. So that's it for logic gates. Now, why? So, yeah, they are elements of a logic expression or a logic circuit, giving 1 as output, and they're used to control data flow with like the ALU, for example, the arithmetic and logic unit. You're trying to calculate things, so you make circuits and do them. And I'll show you a little demo of how they're used. So let's say this is A, this is B, this is C. This is an AND gate, this is a NOT gate, and this is an OR gate. So since this is an OR gate, either this part is true or this part is true, the light bulb would turn on. So this is the AND gate, so you need both for this to come on and this would be true, or this not 0 being 1, so it will already be true, making it true, or both. I'll send the website here.